So in today's class, we are going to learn a new concept of object-oriented programming, which is called polymorphism. So as the name suggests, poly means many and morph means form. Okay, many form. All right. So let's see what does this mean. So in this class, we're going to learn three different types of polymorphism. Okay. The first form is operator, or first type is operator overloading. Second one is method, and the third one is method. Right. These are the three types of polymorphism we are going to learn. All right. So we are going to cover, and I'm going to show you examples of one after other, and then we can see that why the name polymorphism came from. All right. So let's start with operator overloading. Right. So let's take two integers. Let's start with two integers, say a equal to 10, b equal to 20. And then whenever we print a plus b, we get 30. Okay, so let's edit the configuration and let's run it. So we get 30. Okay. So let's see what's happening whenever you are writing a plus b. Okay. So first, let's print the type of a. So if you print the type of a, it will show you class integer. Okay. So what does this mean? What it means is that integer is a class. Okay. And a and b are the object of the integer class. All right. So integer is a class. A and b are the object of the integer class. Clear? Okay. So let's see what's happening whenever you are typing a plus b. So we have learned that a and b are object of the integer class. So then class must be an operator, right? Okay. So instead of printing a plus b, suppose I am writing print a dot underscore add b. Okay. A dot add within double underscore. Let's see what's happening. So you can see that whenever I am writing a dot add b, it is also giving me 30. Okay. So what's happening is the following. Here integer is a class. A and b are the object of the integer class. Okay. And whenever you are writing plus, basically it is calling this method add, which is taking two objects a and b, and then it is returning the added value of a and b. Okay. So here we can see that the plus operator is used as a method that is adding two numbers. Okay, clear to everyone? Okay. Now instead of writing a equal to 10, b equal to 20, I can write say hello and say Amit. And then if I run it, both are showing a plus b as well as this a dot add b are showing hello Amit. But now the type of a is nothing but a class string. Okay, that means string is also a class, and A and B are the object of the string class. Okay, but now this add operator, or sorry, if this add method is behaving as an concatenation function. Okay, previously the add method was adding two integers. Now this add method is concatenating two strings. Clear? So basically we can see that, and here you can see that the add operator is doing concatenation as opposed to addition. Okay, so the same operator is used in different form. All right, the plus operator is used as a mathematical addition as well as string concatenation. Okay, so the same operator is getting used in different form. All right, okay, and this is not only true for just addition. Okay, I can use any mathematical operation. So for example, if I write print A multiplied by B, you will get okay, so let me write, or let me put it in the form of two integers, equal to 10 and 20, and now print A multiplied by B. So now it is going to show you 200. Okay, and instead of A multiplied by B using this multiplication operator, if you print A dot double underscore mul B, you will see that you will get the same result. Okay, so whenever you are basically using this multiplication operator, it is calling this corresponding method, which is taking two objects and then returning the multiplied value of that. Okay. So, and if you want to do the powers, so for example, 10 to the power, let's not make it 20, let 10 to the power 2, then you can use this power function. Okay, A power A to the power B. So then 10 to the power 2 is 100. Okay. So all these methods are basically, or all the mathematical operator that we have used are basically implemented in the form of methods. Okay, that is taking two objects or multiple objects and then doing something and returning some value. Clear? So everything that we have learned in the context of variables, so integer, float, string, all these are basically classes, and then we are declaring different objects, and then whatever mathematical operations we have done is basically nothing but implemented in some or using some methods. Clear? And all these methods are written inside double underscore, so that's why all of them are special method. Okay, so whenever you are calling plus, the add method is called. Whenever you are putting star, the multiplication method is called. Similarly, division operator, subtraction operator, all these operators are basically calling the corresponding methods. Clear? Okay, so now suppose I want to work with some fractional numbers. Okay, so for example 2 by 9, this is a fractional number. Okay, so suppose I want to add 2 by 9 with say 5 by 7. Okay, how can I do so? So in that case, perhaps I need to again as a float, you can get the corresponding answer. If you print 2 by 9 plus 5 by 7, you will get the corresponding answer. Okay. But suppose I want to write a fraction class that is going to keep track of the numerators and the denominators. Okay, all right, and then I want to add two fractional numbers. Okay, so let's see how we can implement the plus operator or any other operator when it comes to a fractional numbers that we want to implement as a class. Okay, all right, so there is no fraction class. So integer class is there, floating point class is there, or float class is there, string class is there. Okay, so let's build our own, or let's build a class at our own called fraction. Okay, so fractions will have two attributes. one numerator and one denominator. Okay, so let's build our own class named fraction, and there we are going to implement our own operator, plus, minus, division, greater than equal to, less than equal to, everything, all the mathematical as well as relational operators. Okay, so let me just comment this out. So let's declare a class fraction. And let's define the init function or init method. So here the init method will take one numerator and denominator. Then I can write self dot numerator self dot. Let's make all the attributes as public. Denominator as denominator. And then let's print, say, numerator equal to self dot numerator equal to self dot denominator. All right. So suppose I want to call two fractional number. So f equal to fraction, and then I need to pass the numerator and the denominator. Okay. So suppose I'm writing, say, 5 by 10, and then f2 equal to fraction of, say, 25 by 10. Let's run it and see what's happening. So it is printing numerator equal to 5, denominator equal to 10, numerator equal to 25, denominator equal to 10. Okay. Now suppose I want to create another fraction number f3, which is equal to f1 plus f2. Right? So here the plus operator I want to use to add these two fraction numbers. Okay. So if I run it, it is going to give me an error because this plus operator is not implemented to add two fraction numbers in the way I want. Okay, I want to whenever I'm going to add fraction number 5 by 10 and 25 by 10, I need to see 30 by 10, right? So the plus operator has not been implemented in the way I want. Okay. So let me use, or let me implement a method that is going to implement the plus operation in the way I want. Okay. Now we have learned that whenever I'm calling the plus operator, basically this add method is getting called. All right. So let me implement my own add method inside this fraction class. Okay. So add, here self is basically referring to f1, and other is referring to f2. Okay, whenever I'm calling f1 plus f2, self is basically referring to f1 and other is referring to f2. Clear? Okay, so if I add two fraction number, one is linked to self, another is linked to other, then the numerator is going to be equal to, so how can I add two fraction number? Suppose I want to add a by b, which this is the first fraction number and this is the second fraction numbers. So if I add these two, I will get a multiplied by d plus c multiplied by b into d. Okay, so basically I multiply the numerator of the first fraction number with the denominator of the second fraction number plus the denominator of the first fraction number multiplied by the numerator of the second fraction number divided by the multiplication of denominator of the both. Okay, so this is multiplied with this will be multiplied with this and then added, and then b and d will be multiplied, and then the denominator is going to be b into d. Okay, so let's use the same trick over here. So if I add two numbers, the new numerator is going to be self dot numerator multiplied by other dot denominator plus self dot denominator multiplied by other dot numerator. So self dot numerator multiplied by other dot denominator plus self dot denominator multiplied by other dot numerator. Okay. That is whatever I have done over here. And the new denominator is equal to self dot denominator multiplied by other dot denominator. The new denominator is going to be the multiplication of the both denominators. Okay. Okay. And then I am going to return a fractional number that is going to be equal to the new numerator divided by new denominator. Okay, so it is returning the fractional number, which is basically f3. Clear? Okay, so let's see. Whenever I am running this program, let's see what's happening. You can see that it is returning a number where the numerator is 300, denominator is 100. Okay, so why it is 300 and 100? Because 5 into 10 plus 25 into 10 is 300. Okay, so the new numerator is going to be 300 and the new denominator is going to be 10 into 10, which is 100. Okay, so the calculation wise this is correct. Okay, so you can see that the plus operator is calling this method and then it is returning the correct number. All right, but in general we do not write these numbers as numerator equal to 300, denominator equal to 100. Okay, we are more familiar with the notation like 300 by 100, something like that. Okay, or 5 by 10, 25 by 10, right? All right. So there is a function or there is a special method called represent. Okay, there is a special method called represent. All right, so how we can represent the corresponding number. All right, so here I want to return a string which is going to be equal to self dot numerator concatenated with a division operator as the string of self dot denominator. Okay, so after this f3, if I print f3 dot represent, okay, so let's see what I am getting. So you can see that I can see, or I will get 300 by 100. Okay, so this represent function I have used to print the fraction number in whatever way I prefer to see. Okay. Now again, we also do not write 300 by 100. We basically write 3 by 1. Okay, so how can I get 3 by 1 from 300 by 100? I have to divide both the numerators and denominator with the GCD, right? Greatest common divisor. Greatest common divisor in this case is 100. So 300 by 100 is 3, 100 by 100 is 1. So I'm going to get 3 by 1. All right. So if I want this, I need to calculate the GCD of self dot numerator and self dot denominator, and then I need to first divide the numerator with the GCD as well as the denominator with the GCD. Okay. Now here GCD is giving a red underline because I need to first import this from the math library. From math import, let's import everything. Okay. So now GCD is not going to give a red underline. Okay. So if I run it, it is going to give you 3 by 1. Okay. So this is the form I want to see. Okay. All right. So here we can see that the plus operator is overloaded. Okay. We are overloading the plus operator and I am basically implementing it in the way I want to implement. Okay. So this is nothing but, or this property is called operator overloading. Okay. So why it is polymorphism? As I said, that poly means many, morph means form. Okay. So that means the plus operator is used in different forms. Okay. First, I have shown you that how to use the plus operator to add two integers. Next, I have shown you how to use the plus operator to add or to concatenate two strings. And now I have implemented my own method to use the plus operator to add two fractional numbers. Okay, so the plus operator is used in different forms. Okay, so that's why this is called polymorph, or this is one type of polymorphism. Okay, the same operator is used in different forms. Okay, clear to all of you? And here I have shown you the example of plus operator. In general, you can use minus, multiplication, division, all the different operators you can overload by writing the corresponding methods, corresponding special methods. All right. Okay, so I'm not showing all the other methods like multiplication, division, subtractions. Let me show you some relational operator. Okay. So for example, I want to write that if f1 is less than f2, then I must print f1 is lesser, else print else I want to print f2 is less. Okay, so here less than is basically a relational operator. Okay, at this point if I run it, it is going to give me an error because less than operator, typically less than operator is used when you want to compare to integer or to floating point or to characters. Okay, but for comparing to fractional numbers, where these fractional numbers are implemented in the way I have implemented over here, less than operator is not going to work. Okay, so I need to use my, or I need to write my own less than methods. Okay. Okay, so this is going to be equal to print. All right. So let me write my own less than method. Okay. So less than is basically LT. Okay, less than. So this is going to return true if f1 is less than f2. Basically, self is less than other. Okay, otherwise it is going to return false. Okay, so how can I write the corresponding method? It's pretty simple. Return if self dot numerator divided by self dot denominator is less than other dot numerator divided by other dot denominator. Okay. So if the mathematical value of the first fraction number is less than the mathematical value of the second fraction number, it is going to return true. That means this line is going to be printed, otherwise this line is going to be printed. Okay. So let's see if I run it whether it is working or not. So here you can see that it is printing f1 is less. Okay. So in between 5 by 10 and 25 by 10, obviously the first one is lesser. Alright. If I make it 50 by 10, then it is going to print f2 is lesser. Okay, because at this point f2 is indeed lesser. So the relational operator can also be overloaded. All right, and again here I have shown you less than. You can implement greater than, less than, equal to, greater than, equal to, all the different relational operator. All right. So this property is called operator overload. All right, and this is one kind of polymorphism because the same operator you are implementing in different forms. So this is a very, very important property of object-oriented program. All right. So in general, you can overload any of these mathematical operators. Okay. So for example, if you want to add two numbers, you can use this add method. If you want to subtract, you can use the subtraction methods. Multiplication, you can use the mul method. In case of division, there are two methods. If you want to get the real division, you can use the true div method. If you want to only get the integer portion of the division or the floor of the division output, you can use float division. Okay. For mod, you can use this mod function. For power, you can use pow function. And if you want to check whether two numbers are equal or not, you can use eq function. Similarly, you can implement not equal to, less than equal to, greater than equal to, okay, negative of a number, absolute value, floating point value, integer portion, okay, and represent I have already implemented it. Okay. So all these special methods you can overload. Okay. Okay. Now, after operator overloading, let me discuss method overloading. Method overloading. So if you just compare the names, operator overloading and method overloading, you can kind of guess that the same method needs to be implemented in different form. That will be method overloading, right? So operators we have implemented in different form, that is operator overloading. Methods, if we can implement in different forms, that is going to be method overloading. Okay. So let's see what does method overloading is. So let me erase, or let me just comment out these portions. So first, let's implement a function called maximum. So f1 dot maximum. This is not a special function. This is the function, or this is the method that I'm going to write. Okay. f1 dot maximum f2. Okay. And I want to ensure that this maximum function is going to return the maximum value of f1 and f2. Okay. Which one is maximum? Let's print f1 dot maximum. So this method I'm going to implement in a minute. So this method is going to take two arguments or two objects, f1 and f2, and then it is going to return the value of the maximum of the two. Clear? All right. So let me just implement the method maximum. And here it is going to take two arguments, self and object. So self is referring to f1, other is referring to f2. Okay. All right. So if so I do not need to write if, it is directly going to return the maximum of self dot numerator divided by self dot denominator and self dot other dot numerator divided by other dot denominator. So basically I'm calculating the mathematical value of the two fractional numbers, and then I'm basically returning the maximum of the two using this max function. Alright. So let's print it. So it is returning 5. Okay. Why 5? Because 50 by 10 is 5. 25 by 10 is 2.5. So the maximum is 50 by 10, which is equal to 5. Yeah. Okay. Now, so till now, everything is all right. Now, I want to use this maximum function not just to compare two numbers, but maybe 3 numbers or 4 numbers. Okay. So for example, I want to use this maximum function for comparing f1, f2, and f3, where f3 is another fraction number. Say f3 is equal to fraction of, say, 35. So I want to use this maximum function also to return the maximum of f1, f2, and f3. Okay. Or let's go one level further. So for example, I want to implement the maximum function in such a way that it can return the maximum of f1, f2, f3, and f4. Okay, where f4 is another fraction number, which is equal to 65 by 10. All right. So the point is, if I pass 2 fractional numbers, it is going to return the maximum of the 2. If I pass 3 fractional number, it should return the maximum of the 3. If I pass 4 fractional number, it is going to return the maximum of 4. Okay. So this maximum method I want to implement in different forms. All right. That is my objective, and that's how the name method overloading came. Okay. The same method I want to implement with different number of arguments. All right. Okay. So at this point, if I run it, it is going to give me an error. All right. So I need to improve this method in such a way that it can take either 2 argument or 3 argument or 4 arguments. All right. So let's see how can I do so. So let's so if it takes 4 argument, so 1, 2, 3. So if it takes 4 argument, let's call them self, other 1, other 2, and other 3. All right. So at max, in this case, it is taking 4 arguments. All right. Okay. So by default, let's make other 2 and other 3 as none. By default, they are none. That means if you do not pass anything, then this is going to be, these 2 are going to be none. If you pass other 2, that means if you pass, so if you pass 2 arguments, that means in the first case, if you pass 2 arguments, then these 2 are going to be none. In the second case, if you pass 3 argument, then this is going to be only going to be none. And if you pass 4 argument, then all the 4, I mean, none of these are going to be none. All right. Okay. So next, I can write that if other 2 is equal to none and other 3 is equal to none. That means this is the case, and this is the first case, okay, where you are passing only 2 arguments, f1 and f2. Okay. If both other 2 and 3, if these 2 are none, then this is the case of 2 arguments. So basically, return the maximum of the first self and other 1. Right. If only other 3 equal to none, else if only other 3 equal to none, that means this is the case of 3 arguments. All right, f1, f2, and f3. In that case, I need to return max of the first 3. Self dot numerator divided by self dot denominator, comma other 1 dot numerator divided by other 1 dot denominator, other 2 dot numerator divided by other 2 dot denominator. Okay, and else if none of these 4 are none, in that case it needs to return the maximum of all 4. So in that case, and to add another mathematical value corresponding to other 3. Okay. So that's it. So in this way, if I implement it, it is going to, or it is supposed to work. Okay. So here I have implemented the same function or same method, but with different number of arguments. So let's see. So now you can see that this is working perfectly. Okay. So maximum of f1, f2 is 5. Okay, because f1 is 50 by 10 and f2 is 25 by 10. So maximum is indeed 5. Maximum f1, f2, f3 is also 5 because f3 is 35 by 10. That is 3.5, which is, so here also maximum is 5. When it comes to f1, f2, f3, and f4, the maximum is 6.5, which is basically 65 by 10. Okay. So the same method I am calling with different number of arguments. Okay. So this is one type of polymorphism because the same method is called in different forms, and this process is called method overloading. All right. So here I have shown you method overloading, where the method is calling with different number of arguments. It may be different types of argument. Okay, so for example, in the first case you are passing to integers, in the second case you are passing to float, in the third case you are passing to strings, and so on. Okay. So this property is called method overloading. All right. So operator overloading and method overloading, I tried to summarize with this example. Yeah. Okay. Now the third form of polymorphism is method overriding. All right. So let's see what does this mean. So let me open a new file and let's name it method overriding. So let's take an example of an animal class. Okay. So class animal, and let's define a method called, say, behave. And here let's print animal makes sound. Every animal makes some sound. Okay. All right. Now let's define a class called dog. Okay, which is a specialist type of animal. So let's inherit animal class. So that means animal, and this dog is going to inherit the corresponding methods named behavior. All right. But here I am writing the same method corresponding to dog, and here I am printing dog barks. Dogs also make sound, but it has a different name called barks. Right. And similarly, let's declare another class called cat, which is also a specialized type of animal or a special type of animal. And let's use the same method, but in this case, I want to print cat mews. All right. Okay. Now, if I type d is equal to dog and then print d dot behave, Let's run it. So let me first edit the configuration. Method overriding. So if I run it, it is going to print dog barks. Okay. So even if both of the child class as well as the parent class has implemented the same method with the same name, the child class method is going to override the existing method of the parent class. Okay, the method of the child class is going to override the method of the parent class. Clear? So this is called method overriding. All right. Similarly, if I write c is equal to cat and then write c dot behave, it is going to print cat news. All right. So here also this behave method has overridden the method that is declared in his parent class. All right. This is called method overriding. This is also one form of polymorphism. Why? Because the same method is basically used in different form. So method overriding is also one kind of polymorphism. Okay. All right. So these are the three different form of polymorphism. Okay. So here, if I do not implement this method, suppose I do not implement this behave method in the cat class, if I simply write pass, then it is going to print animal makes noise. Okay. So if there is no method that is implemented in the cat class called behave, it is going to inherit the method from its parent class. Okay. But whenever I am going to implement the method in the child class, it is going to override the method of its parent class. Okay, clear to everyone? All right. So this operator overloading, method overloading, and method overriding, these are the three different form of polymorphism that I wanted to cover. All right. Now, let me discuss a special type of function called let me discuss a special type of class called abstract class. All right. So let's discuss abstract class and abstract method. All right. So let me use the same example and then elaborate this. All right. So abstract class, as the name suggests, it is an abstract class. It is not the real class. All right. So let's see, what does this mean. So let me give you some example and then I'm going to elaborate the definition and the corresponding details. Okay. So for declaring the abstract class, first you need to import ABC and abstract method. Okay. So here ABC means abstract base class. Okay. You have to import ABC and abstract method. All right. So abstract class provides a template to the other class. Okay. What does template means? Suppose in this example, I want to ensure that all the other, suppose I want to make animal an abstract class, and I want to ensure that both dog and cat must implement the behave method. Okay. Both dog and cat class must implement the behave method. All right. In this example, it is not mandatory that both dog and cat are going to implement the behave method. Okay. Suppose as I said that if I just remove this behave method, it should work. Okay. It is going to run. But suppose I want to enforce that both dog and cat class must implement the behave method. All right, or must override the behave method. How can I ensure this? Let's see. So I want to make animal class the template, and I want to define the behave method as the abstract method that the child classes must implement. Okay. So let's see. So from animal class, I'm going to inherit the ABC, okay, the abstract base class. And suppose I want to ensure or enforce that the behave method must be implemented by the child classes. So in that case, I need to use a decorator or abstract method, and I just need to whenever I'm writing abstract method decorator, behave becomes an abstract method. Okay, and whenever this becomes an abstract method, this method must be implemented by the child classes. Okay, let's see. So if I just remove this behave method, then it is going to give an error. Okay, so in this line it is going to give an error because here I didn't implement the behave method in the child class. So this abstract method ensures that this method must be implemented by the child classes. Okay, otherwise it is going to give an error. All right, and that's why, as I said, that the abstract class provides a template. Okay, here I gave you a template that behave method must be implemented by all the child classes, or behave method must be overridden by all the child classes. All right, so this has become a template. All the child classes must implement or override the behave methods. All right, and if a class consists of at least one abstract method, that class becomes an abstract class. Okay, if a class consists of at least one abstract method, it becomes an abstract class. Clear? So the abstract class cannot be called, okay, because this is an abstract class, this is not the real class. So if I call a equal to animal, it is going to give an error. Okay. Animal cannot be instantiated. Clear? Because it is an abstract class, it is not the real class. Abstract class is only used to provide a prototype or template that needs to be implemented by the child class. This is an abstract class, this is not the real class. So you cannot call the abstract class. This is going to give an error. Okay. So two things that you need to remember. An abstract class will provide a prototype or a template to the child classes. So the abstract class cannot be called. All right. And second point is that in an abstract class, all the abstract method must be overridden by the child classes. Okay, because this will enforce that the same template is used by the child classes. Okay, so in addition to these abstract methods, the child class can implement other methods also. So for example, in addition to this behave, it can implement, say, color, where suppose I am passing a color and then it is printing its color is color. So here, it can call c.color, and here I am passing, say, yellow. Okay. So then it is going to print its color is yellow. Okay, so it can call other methods in addition to the abstract methods, but it must need to implement the abstract method. All right, so here I have shown you just one abstract method. You can call another abstract methods also, say number of legs. Here also I am just putting pass because these methods anywhere needs to be overridden by the child classes. Okay. So in that case also, if I run it, it is going to give an error. All right. So here also I must need to implement the abstract method. Here I am printing it has, or dog has 4 legs. In case of cat also I need to implement it. All right, and now it is going to run perfectly. Okay, so nothing is printed because I didn't print anything. Okay, if I want to print d dot number of legs, then it is going to print that dog has 4 legs. Okay, but if I do not implement this, this is going to throw an error. Okay. So in this way, we can see that the abstract class provides a template that you have to implement, or if you have to, or all the child classes have to override the method that are mentioned as abstract method. So next, let's take an example where we are going to use our knowledge on graphics, correct? And there we are going to implement some object-oriented concept. Alright, so you've already used graphics to plot rectangle, circle, square, and all those things. So in that context, let's use some of the properties of object-oriented programming that we have learned. Alright. So graphics example using object-oriented programming concepts. Alright. So let me just edit the configuration. Okay. So first, let me declare a class called, say, geometric shape. Geometric shapes. All right. So this class is going to implement some of the attributes and methods, and then I want to declare some special geometric shapes like rectangle, square, that are going to inherit some of the properties of the general geometric shape. All right. So all the geometric shapes like square, rectangle, circles, all of them have some common properties. All right. So for example, they have a xy coordinate. Okay. So one of the point xy coordinate may be one of the points of the rectangle, one of the points of a square, or the center of a circle. All right. And then suppose you want to draw something, so all of them will have a color, a outline color, or all of them have some fill color. All right. So let's declare a class geometric property, geometric shape that are going to implement the common properties of any geometric shape. And then we are going to declare some special classes like rectangles, rectangle, square, that are going to implement some other attributes that are specifically important for those corresponding classes. All right. Okay. So let's define the init method, and here I'm going to pass the xy coordinate. Okay. So any geometric shape will have at least one xy coordinate. Clear? So let's write self.x equal to x, self.y equal to y, and in addition to that, let's declare another attribute called fill. Okay, that means suppose you are going to draw the geometric shape, so which color you are going to use to fill up the space. All right, and let's initialize it to none, and self dot say outline. Outline means which color you are going to use to color the outline of that shape. If it is a circle, then the outline, there will be an outline. If it is a square, then also there will be an outline. So suppose I'm going to color the outline using black. All right. So this fill color I am going to mention in the corresponding geometric shapes, but the outline by default I am using black. Okay. All right. Next, let's define methods called getX which is going to return the x coordinate, x, y, which is going to return self dot y. Alright. Okay. So these are two very basic accessor method or getter method. All right. So here I have kept the fill color as none. Okay, the color that I'm going to use to fill up the space is none. So let me define a method called set fill. And here I'm going to set fill. So it should take some color, and then I'm going to write self dot fill color. So basically I'm going to color the corresponding geometric shape with this color. Okay. Now let's define the draw method, which is going to take another argument called canvas. We have already used canvas to plot different objects like rectangle, square, all those things. Okay, so we're going to use that concept. And here I'm going to mention that canvas dot set fill is self dot fill. Okay, and canvas dot set outline is equal to self dot outline. Okay, so basically it is setting the color that you are going to use to fill the object, as well as what color you are going to use as an outline. Okay. Okay, so let's start with this simple geometric shape. All right, it has only 4 attributes: x coordinate, y coordinate, and the color that you are going to use to fill up the space, and the color that you are going to use as an outline. All right, and here I have shown you just 4 simple methods. All right. Okay, now let's declare a class, say rectangle, which is a specialized or special type of geometric shape. All right, so rectangle will have all the corresponding attributes. It will have at least one xy coordinate. Here also you need a color to fill up the space inside the rectangle, and you also need the color as an outline. All right. Okay, so let's declare the init method, and here you will pass the xy coordinate of one of the points of the rectangle, and along with that you need one parameter called width and another parameter called height. Okay, so if you know the xy coordinate of one of the corners of the rectangle and the width and the height, then you can draw the rectangle. Right. The width and the height will be used with respect to this xy coordinate. All right. Okay, so here I'm going to use this init method where I'm going to pass the xy coordinate. All right, and then this width and height I'm going to add separately. Okay, so from its super class, it is going to use the init method, which is going to take 2 argument x and y. Okay, so the init method of its super class will take 2 argument x and y. All right, so super dot init xy, and then in addition to that, I'm going to write self dot width self dot height. All right, so that's it. Okay, Now let's implement the draw method. Okay. Draw self canvas. And here also I'm going to first call the draw method that was implemented in its parent class. Okay, because this draw method will set the corresponding colors that you are going to use to fill up or that you are going to use as an outline. Okay, so you can write super dot. So this super is going to be ended with the bracket. So super dot draw, and here I'm going to pass the canvas. And after setting the colors, I need to draw the rectangle. Okay. So here I can write canvas dot draw rectangle, and here I need to pass self dot x, the x coordinate. Okay. The x coordinate as well as the y coordinate. Get y, and the width and the height. Self dot width, self dot height. So this draw rectangle function we have used before. It takes 4 arguments: x coordinate, y coordinate, and the width and height of the corresponding rectangle. All right. And before drawing the rectangle, I have already set which color I am going to use to fill up the space, which color I am going to use as an outline. All right. So basically, this method is going to plot the corresponding rectangle with the corresponding colors that I'm going to mention. All right. Okay. So let's see whether these two classes, rectangle and the geometric shape classes, are working perfectly. Okay. So here I'm going to use the Easy Graphics package. So from Easy Graphics, import graphics window. All right. So we have already installed the Easy Graphics package in one of our previous classes. All right. Okay. And then I'm going to first open a graphics window. And then canvas is going to be equal to win.canvas. All right. Now on the canvas, I'm going to draw the rectangle. All right. So rect equal to rectangle, and here I need to pass 4 parameters: x, y, width, and height. Okay. So suppose the xy coordinate is say 10, 10, width is say 90, and height is 60. Right. And then rect dot set fill. So I want to fill it up with say yellow color, and then I would like to draw it. Okay. So I am not calling the set outline method because by default I have used black. Okay. So after rect dot draw, I need to put win dot weight, otherwise the screen is going to vanish instantly. All right. So let's see whether this is working properly or not. So rect dot draw. Okay, so draw is going to take the canvas, so I need to pass canvas. So you can see that here I got a screen where a rectangle is drawn and the color to fill up the space is yellow. Okay. So in this window, this is the x-axis, all right, and this is the y-axis. So this point is 0, 0. This top left corner is 0, 0. Okay, and this is the positive x-axis. This is the positive y-axis. So xy means the point, this is x and y, and then the width is 90, the height is 60. Okay, so you can see that the width is more than the height in this case. Clear? So you can see that we have used a rectangle, or we have declared a rectangle class that is inheriting the properties of the geometric class, and in addition to that, it is also implementing its own methods as well as attributes. Okay, and this property we are using to draw the corresponding rectangle. Clear? Okay. Now let's declare a class corresponding to square, which is inheriting say rectangle class. Okay, because square is a special kind of rectangle where the width and height is identical, right? So we can say that square is also a special kind of rectangle. So all the properties of rectangle will come into the square also. The only thing is that the width is equal to the height. That's it. All right. So we can inherit all the properties of rectangle in the square class. Clear? Okay. So let's write the init method. So inside the init method, I'm going to pass x, y, and size. Size means size of each and every edges of the square. All right. So in case of rectangle, I have used width and height separately. Here I'm going to use size. So width is equal to height equal to size. Clear? So I'm going to call the init method of its parent class. Here I'm going to pass x, y, and both width and height is equal to size. That means I'm going to pass size and size as width and height. Okay, that's it. So that will become a square class. Clear? So square is a special kind of rectangle where both width and height is equal to the size. That's it. And as rectangle is the parent class, I can call the draw method. All right, and I can also plot the corresponding square. Let's see whether it is working properly or not. Say square equal to square, and this square I need to pass x, y, and size. Say I want to plot in the same height. I want to plot in the same y coordinate. So y coordinate is equal to 20, equal to 10. X coordinate is going to be say 200 or something. All right, and height and width is equal to say 70 or something. All right, so x-axis is going to be x-axis of the x coordinate is going to be 200, y is 10, and the side is equal to say 70 or something. Okay. And square dot set fill. Say I want to fill this with red color, and then I am drawing this on the canvas. Let's see. So you can see that the square with fill color equal to red is plotted. All right. So in this way, we can see that the square is able to inherit all the properties of a rectangle. All right. So square is inheriting the property of a rectangle. Rectangle is inheriting of the property of the geometric shape class. All right. This is an example of multi-level inheritance. Clear? Okay. So with this, let me draw some of the flags that are very simple to draw. Okay, so that or some of the flags of some countries that we can draw using the combination of either rectangle or square. Okay. So for example, suppose I want to draw the flag of Guinea flag. So the Guinea flag looks like this. it consists of just 3 rectangle, red, yellow, and green. All right. So let's implement the Guinea flag. Let's draw the flag of Guinea. So flag 1 equal to, say, rectangle, and suppose I want to draw around in this place. All right. Around in this place I want to draw the corresponding flag. So the y coordinate is say 100 and x coordinate is say 10, because it is going to be plotted over here. Correct. So x coordinate is 10, 100. Width is, so the width of the first rectangle, the red rectangle, is going to be say 60 and 90. Right. Okay. So the width is less, height is more. All right. So I basically want to imitate this. Width is less, height is more. All right. And then the set fill is going to be red. Flag 1 dot canvas. Okay. So let's see. So you can see that this part is drawn. Okay. This red part is drawn. Next, let's draw the yellow part just by the side of the red rectangle. So how can I do so? Let's see. So here the y coordinate must be identical. The x coordinate is going to be 10 plus the width. Okay, 10 plus the width. So let's do this. Flag is equal to rectangle. The x coordinate is going to be 10 plus width, which is 60. Okay. Width is 60. Y coordinate will remain the same, and the width and height is also going to remain the same. And here I need to use the color yellow. Okay, so the color of the second rectangle is yellow. And then flag dot draw. Okay. So these two rectangle is done. Now I need to draw the third rectangle, which is green. All right. So flag equal to rectangle, and here the y-axis or y coordinate will remain the same. X coordinate is going to be 10 plus 2 into width. Right. So x coordinate is going to be 10 plus width, which is 60, plus another width, which is 60. Y coordinate will remain the same, and the height and width are also going to remain the same. All right. So flag dot set fill, in this case, is going to be green. Yes. Okay. So now we can see that the entire flag of Guinea is drawn over here. Okay. So this is exactly what I wanted to draw. Okay. To all of you. Similarly, I can quickly draw another flag of, say, Yemen. Okay, Yemen flag is also very simple. It consists of 3 rectangles: red, white, and black. Right. So I can quickly draw it. Yemen flag. So flag 2 is equal to rectangle, and let's see where I want to draw. Suppose I want to draw it underneath the Guinea flag. Okay. So the x-axis will remain, or x coordinate will remain the same. Y coordinate, let's put, say, 200. Okay. So x coordinate is 10, y coordinate is 200, and here In this case, the width is going to be more than the height. Okay, so let's put width as say 180, height is 2 dot set fill. So let's see the color. So it is, let's use red. Okay, black 2 dot draw. Okay, so let's see whether the position is correct or not. So you can see that the red part has come. Now I need to draw the next rectangle underneath the red rectangle, which is with color white. All right. So for the white rectangle also, the x coordinate will remain the same. Y coordinate is going to be the previous y coordinate plus the height. Okay. So previous coordinates was 200, 200 plus height. So black 2 equal to rectangle, x coordinate will remain the same, y coordinate is going to be previous y coordinate plus height. And then let's keep the width and height identical. And for this rectangle, the color is going to be white. Let's draw it on canvas. So you can see that the first two rectangle came as expected. Let's draw the last rectangle, which is of color black. So this rectangle will come here. That means the x coordinate will remain the same. Y coordinate is going to be the y coordinate of this point plus height plus height. Okay. So black 2 equal to rectangle, x coordinate will remain the same. Y coordinate is going to be 200 plus height. And then the width and height will remain the same. Then black 2 dot set fill, black 2 dot draw. Okay. So if I run it, it is going to show you this flag. Okay, which is exactly what I wanted to see as the event flag. All right. So using this technique, you can draw some simple flags. All right, that you can draw with rectangle or square. Clear? So in this example, I tried to show some application of object-oriented programming using the graphics package. All right. Now, in general, you can add multiple shapes. So here I have shown you how to add a rectangle and square. Okay. You can add triangle, circle, okay. All the different types of shapes you can, pentagon, hexagon, all the different types of shapes you can implement. All right. So let me show you a better organized way of writing this kind of program. Okay, so suppose you have some 20 shapes. All right. So if you just start writing it one after other, it is going to be a very long program. All right. So you can make it more organized by creating a separate file where you are going to put all your shapes that you want to use. Okay. And then from this file, you can basically call the corresponding shape that you want to call. All right. So let me just cut all the corresponding classes, and then let me just open a new file called shapes. And here let's copy all the shapes that are of your interest. Okay, you can add more shapes like circle, pentagon, hexagon, all the different types of shapes you can put in this file. Okay. Now at this point, this rectangle square is going to show a red underline because it doesn't know what does rectangle and square means. So you need to import the corresponding functions. So from shapes file star. Okay, let's import everything. So now we can see that all the red underlines have gone, and now we can easily run and get your output.